All right, so now we're going to talk a little bit more about our other form of our quadratic functions and how to use those to graph them. And it's a little bit trickier, even though the form of the function, like this guy, f of x equals negative 2x squared minus 4x minus 5, even though that might look initially a little easier to deal with, it's a little trickier to pull apart features of the function, but we can certainly still do it. So looking up here, one thing that I want to point out is, like if you're going to make a flashcard from this section, the flashcard should say, in your vertex, your x coordinate will be x equals negative b over 2a. X equals negative b over 2a. That's the key to this portion. All right, so where does that come from? Well, you guys know the quadratic formula. So this guy, x equals negative b plus or minus square root of b squared minus 4ac, whole thing over 2a, right? And remember, this gives us the zeros of our function. So when we solve for x there, that's giving us our x-intercepts on our graph, right? So the two x-intercepts, in the middle of them would be our axis of symmetry that runs through our vertex. So if we're going to look for the halfway point between our two x-intercepts, the difference between our two x-intercepts is they both start with negative b, they're both divided by 2a. One of them we're going to take negative b and add this square root. One of them we're going to take negative b and subtract that square root. So if we remove that square root altogether, that gets us to the halfway point. Our vertex is going to be visually halfway between our two x-intercepts. So that's one way to think of it. There's another breakdown of this in the e-text on page 350. So feel free to check that out as well, where they go into a little more detail about why x equals negative b over 2a for the vertex. But what I need you guys to know is when you're finding the vertex, step one will be, so to find the vertex, step one will be to calculate your x coordinate, and x is going to equal negative b over 2a. X will equal negative b over 2a. Second step, to find your y value for your vertex, you can plug in whatever that x value is. So that's going to be f of whatever negative b over 2a is. Okay, so that's what this ordered pair is. I know it looks really scary, but when you find negative b over 2a, maybe it'll be like 3. And then for your y value, you're just finding f of 3. All right, so for number 7, we have f of x equals negative 2x squared minus 4x minus 5. We no longer have that standard form, so we can't quickly and easily pick out our vertex. But we can still find our vertex. It just takes a little more work. So a equals negative 2. That's the coefficient of x squared. B equals negative 4. And if you wanted to find c, c is negative 5, although we don't need it for the vertex. All right, so if we want to break down this function and its graph, the direction of the opening, remember we used a before, and we're going to keep that same exact a. So a is still negative 2, which is still negative. So we're still going to have a downward facing parabola. So when we graph it, we're going to have a downward facing parabola because a is negative. To find the vertex, first we're going to find x, which in this case equals negative, and then I'm going to put negative 4, so that's b, over 2 times negative 2. Look at all those negatives. So I have 1, 2, 3 negatives, so my overall result will be negative. So negative 4 up top divided by 2 times negative 2, that's negative 4, but I know my overall result's going to be negative. So 4 divided by 4 gives me 1. I know my overall result is negative from the 3 negative signs, so negative 1 for my vertex x coordinate. And then second step, I just need to evaluate f of negative 1. So in this case, I'm going to take my function negative 2 times negative 1 in parentheses squared minus 4 times negative 1 minus 5. Negative 1 squared is positive 1 times negative 2 will be negative 2. Negative 4 times negative 1 is positive 4 minus 5. So negative 2 plus 4 is positive 2 minus 5 gives me a grand total of negative 3. So negative 1, negative 3 should be my vertex. And by the way, as I'm doing this, I should have done this earlier, let's go ahead and verify this stuff as it's happening in our graphing calculator. Negative 2x squared minus 4x minus 5. So I see my downward facing parabola, and let's see if my vertex calculation was correct. So trace, negative 1 for x gives me a negative 3 for y. So these two look good. Yay, yay. All right, does the vertex represent a maximum or minimum value? Because I have a downward facing parabola, the vertex is a maximum value. And specifically, the maximum value of my function will be that negative 3, the y value from my vertex. So that's the highest function value. My x-intercept, I can see that my entire graph exists below the x-axis. So I'm going to write none here. But if I want to show my work for that, remember we can set our function equal to 0. So negative 2x squared minus 4x minus 5 equals 0. Solving for x in this form, maybe we would use the quadratic formula, for example. So x equals negative b, which would be positive 4, plus or minus square root of negative 4 squared minus 4 times negative 2 times negative 5, whole thing over 2 times negative 2. And evaluating underneath my square root, negative 4 squared would be positive 16. And then negative, negative, negative is going to give me a negative result. 4 times 2 is 8, times 5 is 40. So under the square root, I'm going to have the square root of negative 24, which will be an imaginary number. So all that work to say, no x-intercept. Okay, for the y-intercept, evaluate the function at 0, f of 0. Negative 2 times 0 squared minus 4 times 0 minus 5 just gives me negative 5. So my y-intercept should be 0, negative 5. And if I use my trace function, there's my 0, negative 5. Okay, so let's go ahead and sketch this out. I have my vertex at negative 1, negative 3. So that would be right here. And by the way, axis of symmetry would be at x equals negative 1. I can go ahead and sketch that out. X equals negative 1. No y-intercept, or sorry, no x-intercept. My y-intercept will be 0, negative 5. And based on the axis of symmetry, then I also know that I will have a matching point at negative 2, negative 5 across the axis of symmetry. And once I have 3 points, that's actually enough. If I have my vertex and then 2 other points, I can go ahead and sketch my curve at this point.